Okay, Physics 3-4, we're now moving on to the Day 3 lesson, which has to do with electric circuit components. So what is electric charge? So the attraction and repulsion, that's pushing away of protons from each other, or attraction of protons to electrons, is a result of electric charge. Electric charge is measured in a unit of measure called a coulomb. It's pronounced coulomb. The abbreviation for a coulomb is a capital C. So what is electric potential? So when Stick Boy holds a ball above the ground in the Earth's gravitational force field, it has a potential energy that's measured in joules. And joules is the standard measure of energy in the metric system for any type of energy, whether it's mechanical motion energy, light energy, sound energy. It's measured in joules. So an electric charge in an electric field also has potential energy. So electric potential, which we call voltage, times the electric charge equals the potential energy. The unit of measure for voltage is a volt, and 1 volt times 1 coulomb equals 1 joule. And volt is abbreviated with the letter V. So this is a little bit of a tricky concept. So what I want to do is try to relate voltage to gravity. You have kind of a concept of gravity. So if you let a ball go, if you release a ball, it falls to the ground because it's in a gravitational field and the ball has mass. So it's going to fall down in a gravitational field. In an electric field is like a gravitational field, except it doesn't act on a rubber ball, for example. It only acts on an electrical charge. It only causes an electrical charge to move. So the two things that affect how much energy you get out of electricity is what is the difference, how strong is that electric field, which we call voltage. That's electric potential. And how many electrical charges do you have? How many protons, for example, or electrons do you have in that electric field? And if you multiply those two together, it tells you how much energy you're going to get from the electricity. If we go back to the gravity example, if I drop a ball and it falls to the ground, it has a certain amount of energy. If I were to take 10 balls and drop them at the same time, they would hit the ground with more energy. And that's the equivalent of electric charge. It's how many electrons do you have. In the case of gravity, it's how many of these little balls do you have that you're dropping. Now, if you go to a different planet which is much larger than the Earth, it's going to have a stronger gravitational pull. We haven't talked about gravity in that sense yet, but it will have a stronger gravitational pull. So that's the equivalent of electric potential. So if you drop a ball on this bigger planet, it's going to hit the ground harder with more energy. If you drop the 10 balls on this other planet, they're going to hit the ground with more energy than they would on the Earth. So the two things that affect how much energy a ball hits a planet with is how big is the planet, how much gravitational pull does it have, and how many balls do you drop. When you multiply those two together, it'll tell you how much energy that those balls are going to hit the ground with. So it's the same thing here. If you think of electric potential as the equivalent of gravity, but it only applies to electric charges such as electrons, and you multiply that by how much electric charge, that's how many electrons, that'll tell you how much energy you get out. Do you get out enough to run an electric fan, or do you get out enough to run the San Diego trolley, which runs on electricity? So the energy that you get out of electricity is how strong is the voltage field, the electric potential, times how many charges do you have in it. So what is voltage? Voltage is a measure of how much electrical pressure there is to push the electrons. Again, think of it like gravity, except it applies to electrons. If a garden hose has a nozzle such as the one on the right, it is possible for there to be water pressure even if there's no flow. Similarly, it is possible for there to be electrical pressure or voltage even if there is no flow. So in other words, you can have voltage, you can have this pressure, this gravity, even if nothing is moving. So think of it as you're holding a ball above the ground. Okay, there is still gravity pulling on that ball, but as long as you're holding the ball, you're not releasing it, you're not going to see it move. But that doesn't mean that gravity isn't pulling down on that ball. It still is. So it's the same thing here. You can have voltage, that is electrical pressure or electrical gravity, without having anything move. And in this case, if you have that hose with the nozzle and you don't open up the nozzle, no water's going to be able to flow out, and yet there's still pressure of the water inside of the hose. You could squeeze the hose and feel that there's water pressure there. So what is current? If the water does have someplace to go by opening the nozzle on the garden hose, it will create a flow or movement of the water. So similarly, if electricity has a place to go, it creates a flow. The flow of electricity is called a current. Current is measured by how many coulombs of charge pass a point each second. So think of it as how many electrons pass a point each second is kind of a way to think of it. Current is abbreviated with the letter lowercase I. When 1 coulomb passes a point each second, it is called an ampere. Amperes are abbreviated with the letter A, capital A. And often we refer to amperes simply as amps, A-M-P, amps. What is a voltage source? One of the most common voltage sources of voltage, electrical potential you are familiar with, is a battery. A battery creates an electrical potential because it has a positive side and a negative side. So the battery has voltage, it has electrical pressure, but no electrons will flow unless you put it into something that allows them to flow, that creates a circuit, and that something could be a flashlight, for example. That's a simple example. What is a schematic diagram? So we're going to start to learn how to read and draw these. So a schematic diagram is a kind of stick figure diagram of an electric circuit that we will use to solve electric circuit problems. The schematic diagram for a voltage source such as a battery is shown below. So that would be the schematic symbol for a voltage source. So it has two parallel lines there. You see one of them is a little bit longer than the other. That would be the positive side of the battery. And the shorter one would be the negative side of the battery. And then the lines coming out up and down would represent the wire coming out of the battery, and that could be something such as copper wire. So that's the way you would draw a schematic for a battery. It could also be the outlet of a wall. It could be a wall socket, in other words, where you get energy to plug in things in your wall. That could be represented by this symbol as well. What is needed for an electric current to flow? For an electric current to flow, there must be high potential, conducting material, and low potential. And so there you see a battery. It has a high potential end and a low potential end. And now what you do is the yellow line represents a wire coming out of each end of the battery. And if they go through a light bulb, something such as a light bulb, that will cause current to flow. If that light bulb were not there, there would be no current flowing. Why? Because there would be no difference between the high potential end and the low potential end. The light bulb is using up some of that electricity, some of the energy in the electricity, and that's needed in order for current to flow. Again, going back to the gravity example, if you have a ball sitting on a table, and then you move the ball to another location on the table, it's not going to fall from one location to the other on the table because they're both at the same level. They're both at the same height. So a ball won't move sideways along a table, in other words, because they're both at the same potential. They're both at the same distance above the ground, and so they have the same potential energy. So the ball won't move. Similarly, if you just have a battery and a wire going out of one end and into the other, the electricity will not flow. You have to have something in the middle, that light, like that light bulb, in order to cause the electricity to flow. So what is an electric circuit? An electric circuit exists when a metal wire is set up in a loop with a voltage source placed somewhere in the loop. And it also has to have something like a light bulb in it as well. A voltage source such as a battery contains both a source of electrons and a low potential place called the ground for them to go. What is electrical resistance? Resistance in an electric circuit reduces the amount of current that flows through the circuit and causes a drop in voltage across the resistance. There are two ways to cause resistance. One, by using a device called a resistor, which is designed to produce resistance. Two, by placing a load in the circuit. A load is any device which does useful work, such as a light bulb or an electric fan. So that will cause the voltage to drop. Both of those things, either a resistor or a light bulb or electric fan, will cause the voltage to drop, and that means that the voltage at one end of the battery will be different than the voltage at the other end of the battery, and that's what's required to get current to flow. What is electrical resistance? The abbreviation for resistance is capital R. The schematic symbol for a resistor looks like this. It just looks like kind of a sawtooth symbol. The unit of measure for resistance is an ohm, OHM, ohm. And the symbol for an ohm is the Greek letter omega. It looks like a horseshoe. So that's the symbol that we use for electrical resistance. So here's a summary of what we've learned here. Electrical charge is measured in coulombs, and the coulomb is the charge. A coulomb is a charge on 6.24 times 10 to the 18th electrons. That's just to give you some perspective. It's a whole lot of electrons. You don't need to know that number at all. We would never use that number in class. A volt is electrical pressure or potential, or you can think of it like electrical gravity, except it doesn't act in the way gravity does on any kind of an object like a ball or a piece of wood. It has to be a charge. It has to be a proton or an electron, something with an electrical charge, and that electrical gravity, that voltage, will push that charge one way or the other. Current is measured in amperes, and it's how many coulombs pass a point each second. You can think of it as how fast the electrons are flowing. And resistance is measured in ohms, and it's a circuit element that uses power, slows current, and reduces the voltage. So it basically uses up energy. Okay, and that takes care of this particular lesson on circuit components, and in the next lesson you'll learn how to put together a circuit.